So Bismillah, we will look into another example given in our workbook, page 264. Okay, let's compare. Okay. So the very first mark is for you to decompose this into two different fractions like this. Okay, so to do that, it depends on your denominator value. As we analyze it, here the denominator value x is a linear term. So for us to decompose it, the numerator will be one single constant a, let's call it a, over x. And then this part, x squared plus 6, we cannot factorize further. So meaning it is in a form of a irreducible quadratic. Okay, one quadratic only. So as we are to reformat, okay, or decompose, the numerator will receive in a form of ax plus b. There's an x there, but since that we have used the a for this first factor, let's call it b and c. So it is in the form of bx plus c over this factor. So this format must be correct first, S1. Okay, as is for the statement, must be correct. And then in order to solve for the a and b, we need to get an equation. Okay, so how do we get this equation? We are to combine these two fractions so that we can compare the numerator value. So a times x squared plus 6, there's supposed to be 6 there, 6, and x times bx plus c. Okay, so x multiply x squared plus 6. So then we have a similar denominator value. So we can compare now the numerator value, which is 3x squared plus 2, which is this numerator value. There's some mistakes there. Yeah? It's supposed to be 6. So we continue. There's some mistakes there. 6. So you have to get this equation correct, okay, by comparing the numerator value. Okay, what's the numerator value that we are comparing? This is similar denominator, so we are comparing this to this. Okay, so hence we get this equation. It must be correct. Our a, b, c depends on this equation. Make sure that you show it 1 mark there. And here, on how to get your a, b, c, okay, it's interesting. We are using two methods, okay, by elimination and by comparing coefficients. So if you can see that there's an x there, we can actually get the a by eliminating b and c by setting x equivalent to 0. As x equivalent to 0, we eliminate b and c. Okay, 0 times this is 0. So replace x there as 0, so we get 6a, which is on the right side. Replace x as 0, we get 2. So hence a is 1 on 3. There's a mistakes there made in our exercise book. Okay. After you have got the a, okay, let's substitute back this value of a into this equation that we have had. So we have a is 1 on 3, 1 on 3 x squared. And then 1 on 3 times 6 is 2, correct? So we get it back. Because over here it's hard to eliminate the b and c, right? Okay. Or actually you can get from this equation the c by substituting the x as 0. Will it work? No, you cannot get the color. If you set x to be 0, you cannot solve for the c. So the only method here is to expand it. So we need to show that you are expanding it and then rearranging it. Okay, you are to compare coefficient left and right. So for the coefficient of x squared, okay, as we compare x squared here and x squared there, the coefficient of it on the left is 1 on 3 plus b. And on the right, the coefficient of x squared is 3. So hence we can get the b. So 3 minus 1 on 3, which is 3 is 9 on 3 minus 1 on 3, we get 8 on 3. Alright. As for the C, what is the coefficient of x? On the left there, the coefficient of x is C, but on the right, there is no x. So, meaning C equivalent to 0x. There we solve for the C. Alright, but for the answer, you cannot just stop there. You have to replace back according to your assigned variable. A, B, C are the assigned variable of yours. Okay, so A here, we got the A just now as 1 on 3. So that's supposed to be, as replace here, A is 1 over 3. So 1 on 3x. Okay. As for the B there, C is 0. So the B is 8 over 3. So x, put it back and put back your x squared plus 3. So the B is 8 over 3. You have to replace back for you to deserve the mark of your A. Okay, so far we have 5 marks. Make sure that you show it before you go to integrate. So then only we are to integrate. Since that we have a plus, you can actually separate the integral. Only if we have plus or minus, then we can separate and integrate individually. And here we have 1 on 3, which you can actually put up front the constant and integrate 1 on x. So integral over 1 on x dx is easy, which is ln x. Okay. But for this portion, we need to use a simple U substitution. Make sure that you show all this, okay? Starting with your replacing the U as x squared plus 6, and you get the x. So you have to get everything in terms of a U. So x dx is actually du over 2. Okay. And hence, as we replace it, we get 1 over U. 4 on 3, 1 on U du, which is the integral of it is ln U. Make sure that you show your answer in terms of your assigned variable U, okay, for the A. And last, then only you replace it back in terms of the x variable. So for overall, this question can carry 8 marks. Alright.